Hello everyone, welcome back to this series of short episodes on stylometry in the package stylo. And today I'm going to show you how to set some parameters of the model to make your analysis more reliable. Maybe that's the right description here. So what I'm going to use today is a collection of Greek texts containing the Greek New Testament in Unicode. So I've got those texts. I create some working directory folder, big NT for New Testament Greek, something like that. Very simple, very easy. That's my directory in which I create the subdirectory corpus. This is it. Into which I just grab my texts. I don't want to simply grab them, I'd rather copy paste them in order to keep the original versions somewhere as backup files. But for your reference, the package stylo will not affect your texts themselves. So I'm all set, I'm ready to go. I can launch my R terminal, so I'm going to do right now. I'm launching just black terminal, then R, I'm in. Windows users, Mac users, they've got the R shells, but they can also use the black terminal if they wish to do so. Library, stylo, fine. Set working directory. I put my stuff on desktop, so I say desktop and then New Testament, so NT uppercase NT Greek, right? That was it. And the third step is to say stylo brackets. The graphical user interface pops up, which is what we expected to get, and now we start tweaking with the parameters. For the first time, I usually suggest to just go with the default parameters. This is in order to just check if everything is fine, if all the texts are being read, if there is no code page mismatch, if there is anything if there is anything wrong there. So for the first time, I usually suggest to just click the OK button. But this time, since I remember that my text is not in English, it's in Greek, it's in a different script, in a different alphabet. Just to make sure that I can read those texts, I click other language, but basically this other script that I want to use. And I click OK, and the texts are being written, and there's something appearing on the screen, which is fine. I'm not going to analyze it for the time being. That is just to check out if everything works fine, and it seems it does. So I'm ready to go back to stylo and now to analyze the parameters one by one as they go. So if I type stylo once more, my graphical user interface pops up, and now what I can see is that as it comes to the input, you can take either plain texts as I've done several times before here. You can use XML tag text, you can use HTML, up to you, but in the vast majority of applications you will be using just raw text files. When it comes to the language settings, there's a bunch of options. English with contractions, English all, which means that different kinds of tokenization procedures are being applied. English means that the splitting character is whatever goes, including the space, an apostrophe, a comma, and so on and so on. And contractions, English contractions, tries to take into account those contractions such as I'll, you've, and so on, like 15 or 17 of those contractions are being taken into account here. Same for Latin. There is a regular Latin and a Latin which tries to take into account the fact that some editions do distinguish U's and V's, some editions distinguish I's and J's. So this is the option just to flatten all those differences. It's about Polish, Hungarian, and French, that's self-evident. And CJK is Chinese, Japanese, Korean, and other being Armenian, Greek, Cyrillic, all the non-Latin scripts that I was thinking about, and some people contributed to these non-Latin scripts are included here. So in our case of the ancient Greek texts, such as the Greek New Testament, we'll be using the other option. We are ready to go to the features. Features, which is the very linguistic characteristics you want to measure. In the textual world, those features can be words, combinations of words, syntax patterns. These can be some other measurable linguistic features, such as, grammatical categories. There is many of those. In most of the applications, however, you usually stick to words because this is the easiest type of feature to extract from texts. So the features, this is the basic settings you have to know something about. And you can either go to just words, or you can use the notion of n-grams. N-grams being the combination or a combination of different features. If I take a sentence, a dummy sentence in Latin, be it Latin today, Ni vestra auctoritate sufultus, and so on and so on. This is the beginning of the Polish chronicle by the so-called Gallus Anonymous. If you want to know more about this person, because the question is who this Anonymous actually was, check out our webpage. The description is down below to see what are the outcomes of our stylometric analysis are. So if I take a random sentence in Latin, I can slice it into particular words, so single words. Ni vestra auctoritate sufultus, all those words will be counted separately. Or alternatively, I can go for bigrams. So there's word combinations of two words in bigrams, trigrams in 3 words in a row, tetragrams 4 items in a row, and so on and so on. So in the case of the word bigrams, it would be ni vestra, vestra auctoritate, auctoritate sufultus, and so on, right, for all the text in your corpus. As for letter bigrams, that would be the 2 adjacent letters including spaces. For letter trigrams, 3 adjacent letters including spaces, and so on and so on and so on. So that's my graphical user interface, and I can actually set those either words or characters. If I say words and 1, this means word unigrams, so single words. If I say word bigrams, it will go for the combination of 2 words in a row. If I do so right now, yeah, that's the final outcomes. I'm not going to compare to the previous one because the differences are not substantial. There are, of course, some differences, but these are not substantial. But what I did want to show you, however, is the final directory or the working directory I've created that contains some final results, and you will find here the word list txt file. This is the word frequency list for the entire corpus, which was originally meant to be a diagnostic tool in order to check if you recognize your language, if the splitting of the text was done correctly. So in your case, you will see word bigrams appearing in the order of their appearance, so from the most to the least frequent. If I do the study again with word unigrams, that's it. my word list txt will contain just the most frequent words in this Greek corpus. Kai, ho, de, tu, and eis, to, ton, autu, and so on and so on. So that's fine. I can recognize the words, which is cool, which is a proof that the procedure works fine. I could do the same for letter, n-grams, but you got the idea, right? So you know how to do it yourselves. Back to stylo. So we've got on this features. And now the second very important question is how many of those features you want to analyze at a time. So how big is your feature space, right? How many of those features you want to analyze? You can assume quite safely that very frequent words will introduce some noise into your stylometric signal. At the same time, if you take too limited number of words, your signal will not be strong enough. So the question is, what is the optimal number? And 100 most frequent words being a very common solution. Yet it has been proven that this number of the most frequent words might be bigger, and the results are actually getting better. What I'm doing right now, rather than having just 100 words, I'm saying 200. Please make sure that you say in the maximum and the minimum boxes the same amount of, or the same number. Of course, you can differentiate those two numbers, and there are some reasons for doing so, but we will be there in a couple of minutes. So I say 200 and 200, I do the study again, and that's the final results, which is probably a little bit different. So this is a very good idea how to check what is the optimal number of the most frequent words to be scrutinized, but that's something to be discussed in a separate episode. Okay, back to stylo. This is features. There is more to be covered here. For example, a nice function, a nice parameter to use the features that already exist. Because if you run the package stylo, if you run the function stylo once, it produces a table of frequencies. If you go to your working directory, you will see a table with frequencies. I can open that. You see the frequencies are already there. So we can reuse it. You can reuse them by just checking this existing frequencies box. It will not read the text from the disk anymore. It will just use the already existing table. See how quick it is right now. So stylo, statistics, that's the next tab to be covered, and cluster analysis being the default settings, but also multidimensional scaling. If I go to multidimensional scaling, I can do the analysis. Again, it's, the outcome is slightly different. Same about principal components analysis. Go for the correlation table. There are some reasons, and again, this is about how the principal components analysis works. For the textual data, it is better, I would say, to go with the correlation table, so with some additional scaling of the features. So if I click that, that's my final results of the principal components analysis. Now, the differences between the principal components analysis, multidimensional scaling, and cluster analysis, hierarchical cluster analysis, are really big. Now, in mathematical terms, this is 3 different methods. It's true that the outcomes are very similar, but still they work differently. And I'm not going to cover those differences right now. This very short tutorial is on how to use those methods rather than how to understand them. We've covered 3 basic methods. The first being cluster analysis, the second being multidimensional scaling, the third being PCA or principal components analysis. But there is also a fourth actually method, which is referred to as, here it is, consensus tree or bootstrap consensus tree, and and the idea behind this that the hierarchical cluster analysis dendrogram are not very stable. So in order to increase the reliability of those dendrograms, you perform the analysis for 100 most frequent words, 200 most frequent words, 300 most frequent words, all the way to say 1000, and you make those particular dendrograms vote, and the final results is the consensus tree, so a consensus of those particular dendrograms. And if you want to do such an analysis, and I will actually encourage you to do so, you click the consensus tree, but that's not enough. You go back to features and you differentiate the maximum and minimum. So if you say minimum being 100 and maximum being 1000, and the increment being 100, then you get 100, 200, 300, all the way to 1000. If I say from 100 to 1000 by the increment of 50, I will get 100, 150, 200, 250, etc., all the way to 1000. I'm all set, I guess. So clicking OK. Ta-da! And that's the final results for the bootstrap consensus tree. As you can see, there are some, I haven't said a single word about the outcomes. So we've got the New Testament in Greek here, about which we know it was written by different people, not necessarily by single people, but by groups of people. And the question being if the author of the Apocalypse was the same person as the John's Gospel author. Many different and super interesting questions apply here. So as you can see, the epistles through Corinthians, through Romans are clustered together, and John's Gospel is being recognized to be a separate, discrete text, as is the Apocalypse or Revelation, and the Gospels are clustered together here, right? So the Acts slightly sticking out, but the Synoptic Gospels, as they're referred to as, are being clustered together, which is what we could expect. There's some things that we could not expect, but as I said, this tutorial is on showing you how to use the method rather than how to interpret the final results. So this is very much all I wanted to cover in this episode. You also go to sampling and try to fiddle with the parameters to see what happens if you sample some words from the text rather than taking the text in their entirety. And there is also output, which is also self-evident. You can make a nice PDF. Why don't we make a PDF out of it? PDF, color, with the labels, all is fine. So we make a final dendrogram in the form of a PNG file. And that's how you can make your final results publishable. That's how you can leverage the function stylo from the package stylo to make some exploratory analysis. In the next episodes, I will definitely shift gears and I will say something about supervised analysis, which is way more difficult, but at the same time, way more fascinating. So that's all for today, and thank you very much. Cheers.